welcome back to another lesson. Today we're going to be focusing on protocol analysis using Cisco Packet Tracer. In your studies and in your development of networking skills, it's important that we have the ability to check out what different protocols are working in our environment and how they do their business. This way we can get a deeper understanding of what's going on, and it can also help us to troubleshoot why we are running into certain issues in our environment. Here I have a preloaded environment that I designed to help us see these examples in Packet Tracer. To begin, what I want to do here is I'm going to switch from real-time mode to simulation by clicking on simulation in my lower right-hand corner. Now the first thing you'll notice is that we are currently viewing every single protocol that Packet Tracer is aware of. And what we're going to do is actually eliminate many of these so we can just see the few that I want to focus in on today. So I'm going to click on Show All None to remove all of these protocols. And now I'm going to go to Edit Filter and select just the few that I need. In this case, under IPv4, I want ARP, DNS, and ICMP. Next, I'm going to go to Miscellaneous, and in here I want HTTP and I want TCP. I'm now going to close this, and we can see my list in the lower right hand corner has been updated to just these few protocols. What we're going to do now is we're going to go to client 1 and we're going to do a ping to its router's interface. So I'm going to select client 1, I'm going to go to desktop, I'm going to go to command prompt, and now we're going to do ping 192.168.10.1. Now notice this isn't directly being serviced like we've seen in previous examples. Now we see we've got 2 frames here that have been produced on this client. In this case, I can hover over these and see what's going on. So here my red packet is an ICMP request and my green packet is an ARP request. If I click on my ICMP request, I can see details about this request and what decisions it's making. In this case, I have layer 3 on my outbound area selected, and I can see that this is just a standard ping request. And here we're choosing what interface we want to ping from and what IP address I want to ping to. And in this case, my 4th section here shows that the destination IP address is in the same subnet as myself. So I should be able to reach it just fine locally. Then I go to my outbound layer 2, and here I can see that we're making the decision that this is unicast traffic. However, the next hop IP address is not in my ARP table, meaning I don't know the MAC address of this next host. This is why we have 2 frames currently being created by this host. So in this case, my ICMP request is going to have to wait until my ARP request figures out the MAC address of the remote host. So I'm going to go ahead and close this, and now I'm going to select my ARP request instead. So here I can see I'm constructing an ARP request, I'm encapsulating into an Ethernet frame, and I'm going to send it out my fast Ethernet 0. This is another great chance for us to take a look at what information is in an ARP request. If I go to the Outbound PDU Details tab, here I can see the actual information that's in this given request. So notice that my top section is actually my Ethernet header. Here, most notably, I can see what MAC address am I going to be talking to and what is my MAC address. So this way, the remote device knows who's trying to talk to it. In this case, my destination is all Fs, which in Ethernet defines that this is going to be a broadcast frame. Everybody is going to be getting this within my local broadcast domain. Below this, I can see I have my ARP section. And in my ARP section, I have my source MAC address, as well as my source IP address. And I even have the target IP address I'm trying to figure out. But notice my target MAC address is all blank. This is because this is the information the ARP request is trying to figure out. So what I'm going to do now is closing the PDU information window. I'm going to fast forward this simulation to the next step. So my ARP request is sent to my switch, and if I fast forward it again, notice it sends the frame out all of its available ports. Now this is interesting. Why did my switch send this frame out all of its available ports? Well, we can back up our simulation, select our frame, and figure out why it sent it out all these ports. So I can come here through layer 1 on the inbound, layer 2 on the inbound. I can read through everything here. I can go to outbound layer 2. Now, under outbound layer 2, this is a broadcast frame. The switch sends the frame out all available ports in the same VLAN except for the port that received it. This explains why it sent out all of its available ports. So now I'm going to go ahead and close this, and let me fast forward the frame. And now it's received on router 1, so we can now take a look and see what router 1 is going to do with this. So I can select the frame. Here on my inbound layer, the router receives it because the MAC address matches its own. In this case, it's a broadcast address, so it accepts it. It decapsulates the frame to realize that this is an ARP request, and the target IP address matches its own IP address. As such, this router knows that it will respond to this ARP request. To better see what happens here, I'm going to go to my inbound PDU details. And this is identical to what we saw before. However, when I go to outbound PDU, notice the dramatic difference. Here, my original source MAC address and IP address are now the target MAC address and IP address, and the source MAC address for this router has now been filled in. With this information, and also notice that the MAC address destination and the source MAC address and the Ethernet header have also switched. With these changes, now this frame can actually transfer back through the network directly to my client 1 PC. This green checkmark identifies that this host now has the information it needs to complete the ping request. So now we can see that we're sending out our ICMP request, and it's going to transfer through the network to the router. And in this case, I can select it now that it's on the router, and I can walk through the same steps to understand what's it doing at every single step. Most notably, as we've already pointed out, what's interesting to know here is how these frames, or how the information here changes between these two hosts. Here we can see my destination MAC address and my source MAC address, as well as my source IP address and my destination IP address. And when I go to outbound, you'll notice all of that information changes places, because now the router is the source and the host or the client is now the destination. In this case, I'm going to close that and fast forward it back to client 1. And when I click on client 1 now, you'll see we now have a reply from the router. Now in this case, rather than walking through this again for the next 3 times for the next ICMP request, I'm going to click on real time down here and then click back on simulation to clear out all those events. But we can use this to analyze more than just ARP requests and ICMP requests. What about web traffic? Let me go back to real time, and I'm going to click on client 2, and I want to access this webserver.local web server. To do this, I can go to desktop, I can scroll over and select web browser, and then I can type in the web server's address, webserver.local. And there we go. So now I have my web page. What we're going to do now is switch to simulation mode and see what actually happened during this transaction. So I'm going to go to simulation. I'm going to select my client 2 again. And now I'm just going to click Go. In the background, now we can see that I'm generating a DNS packet. So I can click on this and figure out what's going on. So we're creating a DNS query because right now my client 2 does not know what IP address maps to webserver.local. And I can go to outbound PDU and scroll past Ethernet and IP and the UDP header down here to the DNS message and query section. Here we can see that we're looking for the IP address for webserver.local. I'm going to close that and I'm going to fast forward this until it is received at the DNS server. So now I'm going to select the DNS server. I can go to inbound, but we know what that looks like. So let's go to outbound instead. So if I select this and scroll to the bottom, we now see that we received the request for webserver.local and our DNS answer is going to send back the IP address 192.168.20.20. I'm going to close this and forward the request back to client 2. Now that client 2 knows what the destination IP address is, now it's going to begin what's known as the TCP handshake, or the way that we can validate that we have consistent communication between our two endpoints here. So if I can select this TCP frame, and I can find out what it's doing. So here, if I click on layer 4, what we're doing here is what's known as a TCP sync. So I'm going to fast forward this until it's received by the server. Now I can select the frame over here, and I can go to the outbound layer 4 here, and now I'm doing what's known as a TCP sync ACK. I'm acknowledging the fact that I just received a sync. And now I'll fast forward the frame back to the client PC. And I can click on the frame once again because I need to finish the last leg of the TCP handshake, whereas now I'm sending just a TCP ACK. This is the minimal requirement for communication to ensure that we can actually talk between the source and the destination reliably. So I can fast forward this to send the TCP ACK, and I'm additionally sending my first HTTP request behind it as well. So here I can select on the server. I can see in layer 7 that this is an HTTP request, so I'm going to send an HTTP reply with the information that is being requested. Now received on client 2, I can bring it up, and we now have our web page. This was a pretty detailed example of how you can use Packet Tracer to analyze protocols in your environment. In this case, you can learn a deeper understanding of protocols that are used within your environment and how these protocols operate. This way, you'll have a better understanding of how you can troubleshoot an environment or understand why things are happening the way they are. This is a critical skill to learn when working in CyberPatriot or doing cybersecurity, or if you're just studying for an examination. So with this information, you'll be better prepared to handle any sort of an activity or a challenge that comes from CyberPatriot.